Hello, Birdneck Eagles. This is Mr. Yoshida coming to you from the office at Birdneck Elementary School, where we miss you terribly and can't wait for you all to come back to school in a regular environment again. I do thank you for all the hard work that you've been doing in virtual land and doing virtual learning. Tonight is no different. We're going to have a virtual event tonight called Snowtastic. It's going to be awesome. We're going to read a book, and we're going to focus on reading and math and social emotional learning. And we have all kinds of great things involved. I hope you were able to come pick up some of your treats and have some hot cocoa tonight to join this event and have the best time and create some symmetry with snowflakes and all kinds of great things. I'm proud of you all. I hope you do a great job tonight, and I look forward to seeing you soon. Please remember, we are Birdneck, and we are family. We keep moving forward.
Hello, Birdneck family. Welcome to our Snowtastic Family Night. I am Mrs. Dirks, one of our literacy coaches. We are so excited that you're joining us. We will kick off the night with a reading strategy, a story called The Lonely Snowflake, and some Snowtastic math activities. First, make sure that you have the bag of materials that your parents picked up. Now take out the Somebody Wanted But So bookmark. Whenever we read a fictional story, we can use this reading strategy. While you are listening to the story tonight, you can be thinking about this bookmark. Somebody. Who is the main character? Wanted. What did the character want? But what was the conflict? So, how did the character try to solve the conflict? Then, how was the conflict solved? Now listen carefully while Miss Nash reads The Lonely Snowflake. I hope you have a great night.
The Lonely Snowflake, written by Patrick Stemp, illustrated by Anita Solver. The Lonely Snowflake. Snowflake was falling through the air. She was surrounded by other snowflakes, but she was lonely. None of the other snowflakes looked like her. She wanted to find another snowflake that looked just like her so she could have a friend. Maybe there was a snowflake like her somewhere else in the sky. She asked another snowflake, "Have you seen a snowflake that looks like me so I can be friends with her?" The other snowflake said, "No, but we can be friends. We are both made from water." Snowflake said, "Thank you, but I will keep looking for a snowflake that looks like me." She flew through the sky, still looking for a friend. She asked another snowflake, "Have you seen a snowflake that looks like me? I would like to have a friend." The other snowflake said, "No, but I can be your friend. We are both cold. Brr." Snowflake said, "No, thank you. I will keep looking for a friend who looks like me." She kept falling and flying, looking for a friend who looked like her. She asked another snowflake, "Have you seen a snowflake that looks like me? I am looking for a friend." The other snowflake said, "Sorry, we all look different, but we are both falling from the sky. We can fall together and be friends." Snowflake was sad. She was starting to think that she would never have a friend that looked just like her. She flew to another part of the sky. She asked another snowflake, "Have you seen a snowflake that looks like me who can be my friend?" Other snowflake said, "You will never find another snowflake just like you. But it looks like you already have some friends. Look behind you." Snowflake turned around and saw that the other snowflakes were following her. The first snowflake said, "We are all made from water. We can be friends." The second snowflake said, "We are all cold. We can be friends." The third snowflake said, "We are all falling from the sky together. We can be friends." The last snowflake said, "Even though we all look different, we are the same in other ways, and we can all be friends." Snowflake was glad that the other snowflakes wanted to be her friend, even though she did not look like them. They danced in the wind together as they fell through the sky. They laughed and played, and Snowflake forgot about finding a friend who looked exactly like her. The end.
Hi, welcome to the math portion of the evening. I'm Sue Rosignolo.
And I am Joanne Coet, and we're the math coaches here at Birdneck Elementary School.
Tonight, we'll be making connections between real life and mathematics. So as we begin to start our evening of the math portion, we're going to keep with the snowflake theme, and we're going to take a minute to watch a short video about how snowflakes and mathematics are related.
How do snowflakes form? My snowman makes them. You wish. A snowflake begins to form when a supercooled water droplet in the sky freezes onto a dust particle or pollen, forming a tiny ice crystal. However, when water freezes, its molecules arrange themselves in a hexagonal pattern, thus giving the crystal a hexagonal shape. Now, as the ice crystal keeps falling, it comes in contact with more water. As a result, the water starts freezing on the 6 corners of the ice crystal, causing branches to grow on the corners and thus giving us a beautiful snowflake. Also, as the atmospheric conditions are the same on all sides of the snowflake, the branches grow identically, thus making the snowflake symmetrical. But since every snowflake follows a different pattern to the ground, it encounters different atmospheric conditions. Hence, it is said that no two snowflakes are the same. They all tend to be unique.
So, as you were watching about snowflakes, I'm sure you heard the word hexagonal. Hexagon is a 6-sided polygon. A polygon is a closed, plane figure composed of at least 3 line segments that do not cross. Think about maybe a triangle as being the least number of sides that a polygon could have. Some examples below of hexagons you see in real life. The black section actually of the soccer ball, or some of these other pictures.
So now let's talk about symmetry. Symmetry is when a figure has 2 sides that are mirror images of one another. This line would be called a line of symmetry. A line of symmetry divides a figure into 2 congruent parts, each of which is the mirror image of each other. There are 2 kinds of symmetry. One is bilateral symmetry, in which an object has 2 sides that are mirror images of each other. These are examples of bilateral symmetry. The other is radial symmetry. This is where there is a center point and numerous lines of symmetry. You decide. You're going to decide now at the following pictures if it's bilateral or radial symmetry. Guess which one this is? Is this bilateral or radial symmetry? Did you guess bilateral symmetry? If you did, good for you. You are correct. Okay, you decide. Is this bilateral or radial symmetry? Did you guess bilateral symmetry? If you did, good for you. You are once again correct. Here's another one, boys and girls. What type of symmetry is this? Bilateral or radial? You decide. Did you guess radial symmetry? If you did, you are correct. You are a math genius.
word game. When I say science, what picture comes into your mind? Is it stuff like test tubes and telescopes? Maybe it's computers or microscopes, or living things like flowers or frogs. But did you think of anything that looks like art? A lot of science is really beautiful, and there might be no better way to study the beauty of nature than by looking at snowflakes. Have you ever taken a close look at snowflakes in the winter when they land on your coat or mitten just before they melt? Each snowflake is a six-pointed work of art, as cool and as individual as the ones you've probably made with paper and scissors. But how does nature make snowflakes? First thing to know is the little six-pointed pieces of ice that you and I call snowflakes are really made up of snow crystals. Scientists use the word snowflake to describe the fluffy white things that fall from the sky, which are actually bunches of snow crystals all stuck together. And the journey of a snow crystal begins in a cloud. Up there, water in the form of gas called water vapor freezes around a piece of dust or pollen that's just floating around in the cloud. This forms what's called a seed crystal. And seed crystals can become snow crystals if conditions inside the cloud are just right. As the seed crystal bumps around inside of the cloud, lots of particles that make up water stick to it. The particles that make up water have a very specific shape. They kind of look like the letter V, and when enough of these particles stick together, they form shapes that have six sides, called hexagons. And that's your most basic kind of snow crystal. But if there's enough water around, then more water particles will attach at the little points of that six-sided crystal, each becoming an arm or a branch. From there, all kinds of different things can happen. Even though all snowflakes have six sides, they can end up looking totally different from one another. In fact, scientists have names for more than 30 different shapes of snow crystals. Some are big and flat and are called plates. Others look long and narrow, called needles. Still, others are tall and wide, like columns. And then there's probably the most famous shape, called dendrites. They look kind of like stars that have sprouted tree branches. The shape that each snow crystal takes depends on what the conditions were like as it formed in the cloud. Things like temperature and how much water is in the air can make a big difference if you're a snowflake. So, for example, colder temperatures often make flakes with more pointy and fancy arms, while snow crystals that are made in warmer temperatures and air with less water in it tend to be smaller and simpler. Now, you might have heard that no two snowflakes are alike. A lot of them do look really similar to each other, but scientists think that it would be really hard for any two to end up being exactly the same. That's because the conditions in the clouds are always changing. So the flakes that they make are always changing too. Once a snowflake takes shape, its journey has only just begun. After bouncing around in the cloud for a while, it falls to the ground. And as it falls, it keeps changing, depending on the temperature, the amount of water in the air, and other things like wind that it passes through. Since each flake takes a different path all the way to the ground, each one ends up being slightly different. And that's why scientists say that no two snowflakes are exactly the same, but they're all really interesting and beautiful. So now you know how snow crystals are made.
So now that you know a little bit more about how snowflakes are related to mathematics, take a look at the pictures of these snowflakes for just a minute. What do you notice and what do you wonder? Did you happen to notice that the snowflakes each have 6 points or 6 sides or a hexagonal shape? Did you happen to notice that the snowflakes are symmetrical? Did you happen to notice that they are each different in their own way? So tonight you're going to be doing some activities. Your first activity that you're going to be doing is making a snowflake using the materials that you've been given in your baggies, the construction paper, the pom-poms, the sequins, the glue, the twist ties. Everybody in your family that you signed up for has enough materials to make their very own snowflake. Then you're going to be doing a snowman glyph that we're going to explain. You'll have a link through Seesaw, and that's for parents and students. And finally, students with their parents are going to be doing some symmetrical winter drawings. Stay tuned. Here's your first assignment. Make a symmetrical snowflake using the materials in your baggie. Make it original, make it your own. You might want to start with the hexagon in the center to help you get going. Here are a few examples to help get you started. When you've completed this activity, we're going to ask you to take a picture of it and upload it into Seesaw. When you're done with your snowflake and uploading your picture, you're going to go to your snowman glyph and your winter drawings. You're going to click on the link that you were sent to open your glyph, which is a mathematical representation of data, a pictorial representation of data. You're going to make your own glyph based on your likes and dislikes.
Thank you to all the families who participated in our Snowtastic family virtual event. And we want to wish you and your family
a very happy
holiday season.
Thank you.
Stay safe and warm.